Hey guys, welcome to 9.3. 9.3, we are talking more in depth about parabolas. Now I know that we talked about parabolas in chapter 7. However, we're going to go more in depth here in 9.3. Now, I've brought up these slides to really remind you that we've already talked about a lot of these things already. The axis of symmetry, remember, that's the line that splits the parabola in half straight down the middle. It is the line of mirrors. If you were to fold that parabola in half, you'd get the same thing on both sides, and that's what the axis of symmetry serves as. And then the big thing, the corner piece, for lack of a better term, is the vertex. And the vertex is written in the form of h comma k. This is all stuff that we know. However, we are adding some key components to the parabolas now that we are getting more in depth. Those two main pieces are the directrix and the focus. The focus is a point that always is inside of the parabola. It's always going to be inside of the parabola. So whether the parabola opens up, right, down, or left, the focus will always be a point that is inside of the parabola. The directrix is a line that's going to be perpendicular to the axis of symmetry, or in other words, the directrix is going to be a line that always exists outside of the parabola. Now, if it opens up or down, the parabola opens up or down, the directrix is going to be a horizontal line. And horizontal lines are in the form of y equals. If the directrix is a vertical line, that means the parabola opens right or left. So it depends on whichever way the parabola opens that determines the equation for a directrix. So here's what we need to know. We need to know that there are two types of parabolas. Parabolas that open up or down and parabolas that open right or left. Now, they have different equations. Now, if you're used to this guy from chapter 7, that's great. This is the parabola that we saw in chapter 7 because it opened up or down. And if you remember, h and k were the vertex, and a determined the shape of the parabola. If a is positive, the parabola opens up, like this blue one right here. If a is negative, it opens down, like this red parabola over here. Now, a also helps us determine the shape of the parabola. If a is a number, like 2, -10, 4/3, then it's going to be a skinny parabola. If a is a fraction that's in between -1 and 1, 1/2. -3/4, something like that, the parabola is going to be fat in nature. Now we're introducing a new equation, and if you notice, it looks very, very similar to the one that we learned in chapter 7. The only difference is x minus h is now by itself by the equal sign, and y minus k is found in the parentheses with the square. And the reason why they switch is because if a parabola opens right or left, which variable tells us to go right or left? The x value tells us to. So we can always tell that it's a parabola that opens right or left because x equals is by itself. While before they opened up or down, and the y value tells us to go up or down. So it's going to be y is equal to. So this is a new equation, but it has very similar characteristics as the one we talked about in chapter 7. Okay, so a parabola that opens up or down. A parabola that opens up or down has the equation y minus k is equal to a parentheses x minus h. Sorry about the delay. Mr. Barr came in and interrupted my filming process. Anyway, so parabolas that open up or down, okay, that's going to be in the form y minus k is equal to a parentheses x minus h squared. The axis of symmetry is going to be the x value of the vertex. So in this parabola, the axis of symmetry is the x value, x equals, and notice the vertex is located right here at 1, 2. So the axis of symmetry is going to be x equals 1 because the x value in the vertex is 1. Now, here's the new stuff. Okay, the focus. What we're going to talk about is the focus being c away from the vertex, and the directrix is the horizontal line that's c away from the vertex. Wait a minute. So they're both C away from the vertex, but they're going in opposite directions. The focus, remember, is always inside of the parabola. The directrix is always a line that is outside of the parabola. Now, let's take a look closer at this C value. Okay, so if we zoom in on this new parabola, okay, you'll notice that there's a certain distance from the vertex to the focus. The vertex is located right here, and there's a certain distance. In this problem, it looks like it's about 2. So if you look, there's a distance of 2 between the vertex at 1, 2 and the focus, which looks like it's about 1, 4. So there is a C value, a C distance of 2. If you notice, the distance from the vertex to the focus is a value of 2. Now, this is the same exact value as it is from the vertex to the directrix, which is located down here. Okay, they're always going to be the same. They're always going to be the same. Now, how do we find this C value? Well, if we look at our equation, y minus k is equal to a parentheses x minus h squared, there is an equation that helps us determine what the C value is based on the a value. The a value is equal to 1 over 4c. The other way of writing that, if you were to cross multiply, you'd get 4ac is equal to 1. You could divide by 4a. So c is equal to 1 over 4a. So notice these are basically the same equations, just c and a are switched. This is where we come up with that distance between the vertex and the focus and the vertex and the directrix. Okay, here's all the important stuff that you need to know for parabolas that open right, not right up, but right or left. Okay, so the axis of symmetry is going to be the y value of the vertex. It's going to be the y value of the vertex. So it'll be in the form of y equals some horizontal line. Okay, the directrix is going to be a vertical line that is C away from the vertex. Okay, C away from the vertex. They have to be the same distance. They have to be the same distance. The focus is also C away from the vertex. Okay, so let's look at some examples. The vertex and the directrix of the parabola are given. Find the focus. Now, I have two pieces of information. I'm given the vertex and I'm given the directrix, which means I'm missing one of the three. I need to find the focus. So let's make a quick sketch of what's going on here. Okay, do a quick sketch. The vertex is at 2, 4. 1, 2, 1, 2, 3, 4. Okay, the vertex is located right here. And the directrix is in the form of y equals 2. If you remember, a y equals line is going to be a horizontal line at y is equal to 2. Okay, now I'm given my vertex. My vertex is here in red, and my directrix is this green horizontal line. Now, based on this information, we can know whether the parabola opens up, right, down, or left. Based on the stuff that we know and knowing that directrix is always outside of the parabola, does this parabola open up, right, down, or left? That's right, it opens up. So I can sketch my graph that's going up. Okay, if it's going up, that means my focus has to be inside of the parabola. So it's going to be somewhere in here. Okay, now I can find that exact point because the vertex was at 2, 4, and my directrix was y equals 2. Now, take a quick look at these y values. Why do I look at the y values? Because the directrix tells me to look at the y values. This y value was at 2. This y value is at 4. Remember, the vertex is always in between the focus and the vertex, and then the focus, excuse me, it's always halfway between the focus and the directrix. So if there's a distance of 2 between 4 and 2, that means there has to be a distance of 2 between the vertex and the focus. So based on that information, I'm not going to the right or to the left, which means my focus is going to have the same exact x value as my vertex. But my y value is going to be a distance of 2 from my vertex. So I add 2 to this, so my focus is going to be at the point 2, 6. Now, there are some fancy ways of remembering an equation for the focus or an equation of the directrix, but it's important for you to know that it's always going to be the same distance from the vertex and the directrix and the vertex and the focus. So just remember that it's always going to be the same distance. If you can find the distance, you got a chance. Let's look at another problem. Okay. Here we're given the focus and the directrix. So we're looking for the middleman. We're looking for the vertex. Okay. Let's sketch this graph. Let's see what it looks like. The focus is at 2, 0. 1, 2. 2, 0. That's my focus point. Okay. And my directrix is at x equals -2. X equals -2. If you remember, x equals is a vertical line at x equals -2. So 1, 2, and it's a vertical line because it's x equals -2. Now, based on what we know, is this parabola going to open up, right, down, or left? If we remember that the focus is always inside of the parabola, we know that the parabola is going to open to the right. The parabola is going to open up to the right because the focus is always inside of the parabola. So because the parabola opens to the right, we know that it's in between the directrix and the focus. Now, the directrix is at x equals -2. So if it's a -2 distance from here to the vertex and a 2 distance from here, from here to the focus, okay, it's a grand total of a distance of 4 units. So the x value goes from -2 to +2. And what's halfway between -2 and +2? 0, which means my vertex is going to be at 0, 0. So you were just able to find the vertex based on the focus and the directrix. Now we have to find a whole equation. Now, the very first thing we have to do is we have to find the vertex and we have to find the a value. The vertex and the a value is everything that we need in order to solve this. And we need to be able to tell, does this open up or down or right or left? So the best way to do that is to sketch what the graph would look like. So the focus is at -2, 0. There's my focus. And my y value for the directrix is 3. So y is equal to 3 is 1, 2, 3 up here. It's a dotted line at y is equal to 3. Now, based on this information, does this parabola open up, right, down, or left? If the focus is down here and the directrix is up here, then the parabola has to open down because the focus is always inside of the parabola. Now, what's halfway between the y value of 3 here and the y value of 0 here? 1.5. So this vertex has to have a y value that's halfway between 0 and 3, which is 1.5. Now you could write that as 3/2. It's the same thing. And remember, the x value, since I'm not going to the right or to the left, I go straight up, that x value is still going to be -2, just like in the focus. So I've found that my vertex is -2, 3/2. I'm going to put 3/2 just for the sake of simplicity. Okay, and now I need to find what the a value is. Remember, a is equal to 1 over 4c, and c is the distance from the vertex to the focus and the directrix. It's the same distance, remember. Okay, so we need to determine, well, how far is the distance from the focus to the vertex? Well, we just found that if that's 0 and that's 1.5, then a distance is 1.5. So c is equal to 3/2. So a is equal to 1 over 4 times 3/2. So we need to solve for a. A is equal to, the 2 and the 4 can reduce. We get 1/6. So I can put this all together, the vertex and the a value. So I end up getting, because it's opening down, it's going to be y minus k is equal to a x minus h squared. So y minus 3/2, because that's the y value of the vertex. My a value is 1/6, and my h value is -2. So it's going to be x plus 2 squared. Now, this parabola is opening down. This parabola is opening down, which means my a value has to be negative. It has to be negative. So there is my final equation for this parabola. Let's do one more example. So here we have x squared is equal to y plus 2x. Now this isn't in that nice cookie cutter equation that we were given at the very beginning, but we can make it that way. But the question is, okay, is this going to be an up or down parabola, or is this going to be a right or left parabola? Here's the hint. Whichever variable is only raised to the very first power, it cannot have an x squared. The variable that is only being raised to the first power tells you whether it goes up or down. Because if you remember, here are the two equations. Notice that this tells me if it opens up or down, and this tells me if it goes right or left. So it's only the one that's being raised to the first power. These ones will eventually be getting squared because they're inside the parentheses. So looking at this problem, does this parabola open up or down, or right or left? That's right, this parabola opens up or down. So I'm going to get all of the x's together. Is equal to x squared minus 2x. Now it's getting closer, but notice I'm going to have some parentheses in here, which means we're going to have to complete the square. Remember, I'm going to add b over 2 squared to both sides. So I take -2, I divide it by 2, I get -1, and -1 squared is 1. So I add 1 to both sides of the equal sign. Y plus 1 is equal to x squared minus 2x plus 1. Now, I'm one step away. Now all I have to do is I have to factor. So x squared minus 2x plus 1, I'm end up getting x minus 1 squared. Okay, so it's asking, what's the vertex, what's the focus, what's the directrix, and what's the axis of symmetry? So the very first thing I should do is I should find the vertex. That's the easiest one to find because it's h comma k. Take the x value and then the y value. So my vertex is going to be +1, -1. The second easiest to determine is the axis of symmetry. And if you remember, if it's a parabola that opens up or down, the axis of symmetry has to cut it in half, so it has to be a vertical line that cuts it in half. And vertical lines are always in the form of x equals. Well, what do you think that axis of symmetry, that x value should be? The same one as in the vertex. So x is equal to 1. Now, we have to find the focus and the directrix. Now, usually I use the c value to help me find the focus and the directrix because the focus and the directrix are both c away from the vertex. But I am not given a c value, but I am given the a value. It's imaginary right there because it's 1, because it's just nothing's up there, so it's a 1. So if my a value is 1, c is equal to 1 over 4a. Well, if my a value is 1, c is equal to 1/4, which means the focus and the directrix are a distance of 1/4 away from the vertex. Now, based on this a value of 1, does this parabola open up or down? Because the a value is positive, it's going to open up, which means from the vertex, I'm going to have to go up in order to get to the focus. So the focus here is going to be 1 because it's not going to change. I'm going straight up from the vertex to the focus, but I'm just going up 1/4. So -1 plus 1/4. In order to add and subtract fractions, we need a common denominator. And I end up getting -3/4 as my y value in my focus. Now I have to go 1/4 away from the vertex, but in the opposite direction. So since this was 1, -1, I have to go down 1/4, which means I'm going to be subtracting 1/4. Need a common denominator in order to add and subtract fractions. So I end up getting y is equal to -5/4. This is everything that we will need. I hope this helps you get ready for the more complex problems in Chapter 9 when we're talking about parabolas. I hope this helps. Please, please, please come see me if you have questions, and I look forward to seeing you guys in class. Have a great night.